All right, hi everyone. I'm Pry, and welcome to this modern C lecture series. So let's just talk about first, like the scope of the series, what I'm going to cover. This is going to be an intermediate course on C. This is not a beginner programming course per se. I don't think it would be the best introduction. But let's say you have some experience with some other programming language and you want to learn C. I think that this would be a valuable resource for that. And we're going to be really learning how to write C11 and C17. And we're also going to really be focusing on the spec and writing things that are compliant to the spec so that they're portable across every implementation of C11. This does mean that we're not going to be really focusing on platform-specific stuff, such as like POSIX or like Linux syscalls. I do want to cover those at a later time, but for now, I'm just going to talk about C, the programming language. So here's some of the topics we're going to cover. We're going to be covering the C type system. I think that's quite important. Pointers and strings, and the minefield that those are in C. The C memory model, how to do buffered I/O, project organization, bits of the standard library that I think are important, how to do generic programming in a language that doesn't have generics like you might be used to, and how to deal with threading and atomic operations. So, yeah. So this is episode 0. We're going to be talking about the history of C, a bit of computing philosophy, I don't really know what to call it, and some setup. So as you can see behind me, this computer here is the PDP-11. And wow, is it huge. But this is the computer that Dennis Ritchie used in 1972 to make C. He was really writing this operating system called Unix, and I believe he wrote it in PDP-11 assembly at first, and then he eventually wrote it in C, and developed C as a language to do so. And C as a language is very integrally connected with Unix. And it's also very integrally connected with being like a systems language. It's being as a language that is meant to be used for development of operating systems. So I think that's quite important. And Unix as a language became super popular. Unix exploded across a bunch of college campuses, particularly because they were quite open with it. I mean, it wasn't actually open source or anything, but they did freely license it to colleges, and so as it spread, C also spread. So here's some versions of C. There's C89, which is also known as ANSI C. This is the version of C that's probably the most portable. It's just available everywhere. If you've got a microprocessor, you can probably write C89 for it. C99 is just another standardization of it, plus a bunch of new features. And C11 also adds a bunch of features. The reason I put C11 and C17 together is because, for one, I'm calling them modern C, and then two, C17 doesn't actually add any new features. It's more of like a clarification sort of update. So everything that I'm saying for C11 really does apply to C17 as well. And I could have called it C17, but they're really just, we can act as if they're the same. So now let's get into sort of what I call the hierarchy of programming languages. And I really want to emphasize this point that maybe you know or not, but programming is all about trade-offs. There is no silver bullet, right? And so when we make a decision in programming, it's almost always going to be a trade-off. And so even just the language that we choose to write in is a trade-off. If we choose to write in assembly, for instance, for one, it's not portable at all. It's platform-specific, but it's going to be super fast. But it's not going to be super fast to write because of how just like tedious it is. And the opposite is true for something like Python or like an interpreted language. Those languages are super fast to develop in, super powerful, but slow relative to something like C or assembly. And also, yeah, it's sort of the trade-off you make. And so C is also this low-level language, but what's nice about it is you can think of it almost as like a portable assembly language. It's a language that's still low-level. You can write operating systems in it, but it's also just very portable. So that's one of the greatest draws of C. And then other languages are built on top of C and so on. And there are now competitors to C, but right now C is quite ubiquitous. I don't expect it to go away soon. C is also a compiled language. What that means is that C you have to take a C file and then use a program called a compiler to convert it into something that the computer can read. Um, these like .exe files on Windows or like just executables in general. Those are files that contain like binary information that the processor reads and can figure out what to do. They're instructions for the CPU. And so we actually have to compile it first. But this perhaps inconvenient step also ends up making our code much faster. And later on, I would love to talk about compilers as well. So next, we're going to talk about um, writing C in the current year. Why would we write C? Well, like I said, C is a systems language and it's the lowest level portable programming language. And I also sort of like to consider C as like a sports car. It's fast. It really gives you fine-grained controls over your computer, and it requires a lot of understanding to use it. So if you're someone who doesn't know too much about it, it can be very easy to shoot yourself in the foot. And it's, I think, in that way, a sports car. So when do you want to avoid writing C? Well, I do want to instill this idea of using the right tool for the right job. C wasn't designed for concurrency, and I mean, now we've added some concurrency stuff, but maybe if you're writing like a web app that really has to be highly scalable or whatnot, maybe using Go is better, or maybe using Rust is better. Um, C string handling is weird. If you're writing something with a lot of strings, I mean, maybe that's not the best thing. And then also when performance isn't a primary concern. As for security concerns, yes, every other language can also have those security concerns, but C makes it especially easy to do like buffer overflow attacks and so on. And also, C isn't the fastest to develop in. Other languages are much more productive. And so if you're optimizing for time of development, maybe use something else and then switch to C when you need to. So let's set up our development environments. So here on Windows, we have to use MinGW, which is this sort of package for the GCC compiler. Makes it very easy to install for Windows. And as for text editor ID, you can use anything. Notepad++ I think is great. VS Code is also nice. Okay, so we've cut to how to set it up on Windows. So just open up your web browser and let's search for MinGW. MinGW, this should be the first thing. It's just a SourceForge link. And we hit download, and you'll get some executable. Let's get the setup. And once you do that, you have to click install, and this will install the MinGW installer. Once you do that, we can open up the installation manager. This is what's going to pop up. And we want to select the GCC. So main thing is you want to pick MinGW 32 base, and this is a basic installation. It'll give us just GCC, which has got the compiler, linker, and everything we want. You should be able to click this Mark for Installation button, and then after that you should be able to apply changes. Once you do that, you should be all set. Further note though, we do have to edit our path variables. So let's just type in path into the Windows sort of search bar, and it should pop up with this edit system environments variables. We go here and go to the environment variables. And so here's something that's important to know. If we go to C MinGW bin, this is where our compiler is now installed. We've got gcc.exe. We want to add this directory to our path because we want to be able to run it through the command line. So you have to open up your path system variable, hit edit, and add this path into your environment variables. Hit OK, and hit OK, and just save that. Hit apply, right? And finish that up. And to make sure you did everything correctly, let's open up the command line and type gcc. If it says GCC fatal error, yeah, this is awesome. You've got it working. Um, if it says like command GCC not found, then you messed up somewhere, and you should once again make sure install this properly and edit your system variables. Maybe try restarting, but that should be it. For Linux, I mean, if you're using Linux, you really should know how to install stuff, but just use your package manager, apt, pacman, whatever it is for your distribution, and install GCC or Clang. Both work fine. I love both. They do the same thing. And just once again, use any text editor. Your distro probably has one by default. If not, you can pick up Vim or Emacs. VS Code also works on Linux, so anything works. All right. So here I've just got a fresh installation of Debian, and let's open up the terminal. And how do we install GCC? GCC is already installed by default, but let's say for some reason you don't have it. Do sudo apt install GCC. Just put in your password, and there we go. We have GCC installed. And let's just quickly look at how to compile a C program. So I'll just make one called, let's just remove this as well. I'll make something called main.c. And don't worry about this just right now. I'll just make a very quick test sort of program. All right. And we just type gcc main.c. And now we have this file called a.out. You just do ./a.out, and it runs our program. So here we have a working GCC compiler on Linux. And finally, for OS X, I actually can't show you this one, unfortunately, but you should be able to install GCC through Xcode, and then once again use any text editor that you want. As long as you can edit text, you'll be fine. All right, thank you for watching episode 0. I'll be sure to come out with more of these soon, and thank you for watching. Bye.